So today we shall discuss about current electricity chapter. So in this current electricity, first of all, let us take a small example. Yeah. So I am taking a simple circuit having EMF M or EMF E, and the current is passing through the wire. And let us imagine that there is a bulb here. Okay. So when you connect this bulb to a battery, you should know one thing, that the bulb is going to glow here. Okay. The bulb is glowing here because the current is passing from higher potential to lower potential through the circuit here. Okay. So if the current is passing from higher potential to lower potential here, then what is going to happen? I will take a small part of the wire here. This much part of the wire I will take separately, and we shall study what is going to happen. So I am taking this wire separately, and if the battery is connected to this wire, positive terminal, negative terminal, and you should know one thing, that inside this there are number of free electrons present here. There are millions and millions of free electrons, and there are also positive ions present in the. So what is this actually? This is a part of a wire, and what type of wire it is? It is a copper wire. Okay, so I am taking a copper wire separately, this much part of a copper wire separately, and studying what is going to happen in this. So here you are connecting positive terminal, here you are negative terminal of a battery, you are having EMF E here. Okay, so then what is going to happen? Electrons are negatively charged, they will try to move towards left by taking multiple collisions. What is going to happen? Let us see here. Okay, so this electron, if it tries to move here forward, what happens here? On its way, there are number of free electrons are there, number of ions are there. It will collide multiple times and comes out here. It will collide multiple times and comes out. Now let us imagine that the length of the wire is taken as L, which is nothing but drift velocity into time here. Because you should know one thing, that distance is nothing but velocity into time. Here I am taking length of the wire as L, and it is nothing but velocity, which is said to be the drift velocity into time here. Why I have taken drift velocity into time here? Because electrons are not moving in a straight line. There are multiple collisions and they are moving forward to the positive terminal. As if they are taking multiple collisions and moving forward, this type of velocity is said to be drift velocity. Okay, so let us see what is going to happen here. Length is equal to drift velocity into time here. Okay, so now you all know current I is nothing but rate of flow of charge. Current I is nothing but rate of flow of charge. And according to electrostatics, you should know that Q is equal to N into E. Q is equal to N into E. Number of electrons present in this wire into charge on the electron. You know about this, isn't it? So I can take here now I is equal to NE by T. Okay. So we will study what is the meaning of N here. Okay. What is the meaning of N? See, you know that what is N? Number of electrons, total number of electrons present in this volume of a wire V. V is said to be the volume of this small part of a wire, and number of electrons present in this is N. So this product is taken as capital N. Hope you are understanding. So capital N is nothing but small n into V, because small n is nothing but capital N into V here. Okay, what is the meaning of capital N into V? Number of electrons per unit volume. Okay, so what is small n here? Small n is nothing but number of electrons per unit volume, but what is capital N is nothing but total number of electrons present in this volume. That is, capital N can be taken as small n into V here. Okay, so therefore capital N is equal to small n into V. Volume is nothing but area into length. Okay, volume is nothing but area into length. Just now I told you that length is nothing but drift velocity into time here. Okay, so this is small velocity, smaller v we are taking it as velocity, and capital V we are taking it as volume here. Okay, so therefore this length is taken as drift velocity into time. So totally, what is the formula for n? Is going to be small n. So capital N is equal to small n into V. Volume is area into length means velocity into time. So totally, what is the volume? What is the value of? What is the formula for capital N means small n into A into Vd into T. Okay. So you have to substitute this value here. You know. So I is equal to NE means N means you have to write all these things. NA small Vd into T in the place of N. Here E by T. Okay. So TT gets cancelled. Therefore, I is nothing but NEAVD. Okay. So this is the formula for current here. What is the formula for current? Current is nothing but NEAVD. Okay. What is A? A is nothing but cross section area of this wire. What is E? E is nothing but charge on the electron. So therefore, the value of E is nothing but 1.6 into 10 power minus 19 coulombs. A is said to be area of cross section. N is said to be number of electrons present. Okay, so this is the formula for I here. Okay, I means current passing through the wire. Okay, so what can we still modify this formula? You can just see. So just now I got I is equal to NEA VD, is it? So this is the formula for I here. Now let me discuss what are the further modifications we have to do here. For example, this is a positive charge and this is a negative charge in a battery. Whenever there is some negative charged particle like electron, what is going to happen to this electron? Having initial velocity z, this electron tries to move in this direction. It is attracted towards the positive terminal, right or no? It is attracted towards the positive terminal. So what is the force acting on the electron here now? Force is nothing but Q into E. You all know about this. Force is nothing but Q, and force is nothing but M into A here according to Newton's laws. Therefore we can make them equal. MA is equal to QE. Therefore A is equal to QE by, isn't it? Okay. So here initial velocity is 0, here final velocity. Let us imagine the final velocity here is taken as V. Okay. So what is going to happen here? For example, there is one electron here. There is one more electron here. There is one more electron here. So this electron, when it collides the another electron, suddenly its velocity drops and its velocity is going to be 0. After collision, again it goes for the next collision. Am I right or not? It goes for the next collision from here to here. There is some time for relaxation, and that is taken as tau, which is said to be relaxation time. It is called as relaxation time between the two collisions. Initial velocity, and here we are getting final velocity, and this final velocity is said to be drift velocity. You should know one thing, that V is equal to U plus AT according to equations of motion. Initial velocity just after collision, and after colliding here, it will not stay here only, it will again go and collide with the next particle. Okay. So therefore U is going to be 0, V is equal to A into tau here. Okay. Time is taken as tau here. Tau is said to be relaxation time. Means between two collisions, there is some time for the electron to relax. That is said to be relaxation time here. So velocity is nothing but, what type of velocity it is? Drift velocity, nothing but A into T. Is it okay? So drift velocity is equal to A into T. Therefore drift velocity is nothing but, A means just now we got QE by M. So QE by M into tau here. We got one more formula for drift velocity, that is VD is equal to QE by M into tau here. Therefore I will take this now, NEA. VD means again we can write this as QE by M into tau here, is it? Okay. So what I am going to get now, I is equal to NEA QE by M into tau here. Okay. This formula now. This formula here. Then what is the relation between potential difference and electric field intensity? See, I told you already that electric field intensity is nothing but potential difference by length. Is it? Why is it so? Because the formula for electric field intensity is Q by 4 pi epsilon naught into R square, whereas electric potential can be taken as Q by 4 pi epsilon naught into R. This is the formula for electric potential. Okay. Why we have to consider these formulas? We shall discuss in details here now. So first of all, I told you that, for example, any charged particle is there, another test charge is there, Q naught, and this is Q. Let us take two charges are having certain distance R here, and you know force is nothing but Q1, Q2. Q1 is nothing but Q2 is nothing but Q naught. Q1, Q2 by 4 pi epsilon naught into R square. Okay. So this is said to be force between the two charged particles. And I told you that electric field intensity is nothing but force experienced by unit charge. In simple way, electric field intensity is nothing but force experienced by. Therefore, electric field intensity is nothing but Q naught by 4 pi epsilon naught into R square divided by Q naught. So Q naught gets cancelled. What is left now? Electric field intensity is nothing but Q by 4 pi epsilon naught into R. So this is said to be electric field intensity formula. Then what is the formula for electric potential? So from this formula only we got this formula. Okay, that is electric field intensity is nothing but Q by 4 pi epsilon naught into R square. Then how did we get this formula here? We shall discuss in details. Okay. So first of all, for example, there is any charge and this is said to be electric field. At this particular point, you have to find out electric potential. Then what you do to find out electric potential? You have to do certain work here. What is the work done by you? You have to bring any test charge Q naught from here to here. Okay. You have to bring any test charge from infinity to that point. So electric potential is nothing but work done on unit charge to bring it from infinity to that point. That is said to be electric potential. So electric potential formula, and work done is nothing but force into displacement by Q naught. What is the force here? Just so we got the force. Q naught by 4 pi epsilon naught into R square is the force, and already one R is there, and here one Q naught is there, R square gets cancelled, R gets cancelled, Q naught gets cancelled. What is left now? Q by 4 pi epsilon naught into R. This is going to be your formula for electric potential. Okay. So what is the difference between these two formulas? In V, in the denominator one R is less. Here R square, here R is there. Therefore, if you want to make a electric field intensity equal to V, if you divide the V with one more R, you will get R square, isn't it? So V in the R to divide just the R square, so then it will become equal to electric field intensity. So what is the relation between electric field intensity and electric potential means? E is equal to V by. Therefore, here in this case we can take E is equal to V by L. Why? Because we have taken the length between the two collisions is taken as L, or the length of the wire we have taken as L, isn't it? Length of the wire, how much we have taken as length L here. So E is equal to V by L. So here already E is present. I will take this as I is equal to NEA Q tau by M. So instead of E, I am taking V by L. Is it understood? So I is equal to, what are the things to be separated? You can just see here. No, V by L you are getting. So I will just take V in the numerator like that only, potential, and I will take ML Q. Q na? Okay. So what is the meaning of Q here? For a single electron, charge will become E, because Q is equal to NE. Q is equal to NE, and for one single electron N equal to 1 means Q is equal to E we can take. So when you take Q is equal to E, here we can change that it is going to be E by M. Okay. Here also we can change E is also becoming E by M, isn't it? So here also we can remove this charge and replace it with E. So what are we going to get now? NE square, isn't it? NE square A by tau, isn't it? So this is said to be the formula for I is nothing but already potential is there by R. So this can be made equal to, what is that? I is equal to V by R according to Ohm's law. What is that? I is equal to V by R according to Ohm's law, because V is equal to IR. Ohm's law says that potential is nothing but current into resistance. So we got I is equal to V by R. From this we got one formula for R also. What is that R? R is said to be resistance. Why it is called as resistance here? Because the electron which is moving forward, it is not moving smoothly. It is taking number of collisions. It is facing lot of opposition to move forward. It is facing lot of resistance to move forward. That is said to be resistance is nothing but opposition to the flow of electrons, isn't it? So therefore, finally, what are we going to get now? We are getting something, what is that? This formula. Okay, I is equal to V by R. Then what is R here? Let us see R. R is equal to ML. This one. This is the value of R now, isn't it? So we will take it separately. So R is equal to ML. What else you are getting? Just see. NE square A tau. Is it? NE square into A. Is it? So I will do one thing here. I will take this as NE square tau separately into L by A. So you also know, according to your electricity chapter, which is already completed in your 10th class, this is taken as rho L by, isn't it? Alright? Resistance is nothing but rho L by A. You have heard about this? Rho L by A in your 10th class. So what is the meaning of this rho? Rho is said to be specific resistance. Okay? It is said to be specific resistance. For a particular conductor, there is a resistance which is said to be specific resistance, because we are all talking about conductors. Copper is a conductor, zinc is a conductor. All conductors is having specific resistance, isn't it? So rho is said to be specific resistance. Then what is the value of rho here? It's said to be into tau here, is it? That's why we used to say in electricity that resistance is always directly proportional to length, and resistance is always inversely proportional to area of cross section of a wire. So let us imagine this is a wire here. This is a wire having area of cross section A and length is L. That means a wire is having greater length, it is having greater resistance. Okay, it is having wider area, resistance decreases, because inverse relation. Area increases, resistance decreases. Length increases, resistance also increases. Okay, so we got the formula for, what is that? Specific resistance. So we got the formula for specific resistance. Also we got a formula, that is rho. How much we got? Rho is equal to, this is going to be a formula for specific resistance according to microscopic view of resistance. So microscopically we studied how electrons appears to be inside and how all these things are going to happen. Understood? So let us discuss about what is the meaning of conductivity. See, conductivity is given by letter sigma. Okay, so conductivity is given by letter sigma. See, conductivity is reciprocal of resistivity. Conductivity is always said to be resistivity, reciprocal of resistivity. That means the formula for conductivity is how much? N E square tau by m. Okay. So this is the formula for conductivity. Hope you are understanding what I am telling. So conductivity got, how many formulas we got? Just see here. Many formulas we have discussed till now. We got this as the first formula, current. Okay. So current, the another formula for current we got here. Is it? So what is that formula? This formula, that is I is equal to Ne square A tau by. So this is one more formula which we have studied for current. Okay. What we have done? Just we got the current formula, the first formula as this one. Just Vd we have taken here. Vd is equal to E into capital E by M into tau. If you multiply here, you are getting this much big formula here. Okay. So here only we can change that is, what is that? Vd means we will write E into capital E by M into tau here. Okay. So I will be getting here N E square A E tau by M. Okay. And again we have taken E is equal to V by L. So step by step if you do, you will understand. Otherwise you don't understand anything here. Okay. Drift velocity formula. Next, after current, we got another formula. From the current we have taken resistance, is it? So from the current, according to Ohm's law, V is equal to I is equal to V by R. So we got R is equal to ML by Ne square A into tau here. So this we got. Again we have taken some parts separately. That is rho. Another formula for rho we got. So rho is taken as M, Ne square tau. And again conductivity also we got the formula Ne square tau by M. Okay. So let me discuss about, these are all basics of your electricity. So we shall discuss one more concept which is called as current density, which is given by letter J. Current density. Okay. So what is a definition? What is a formula for current density? See, current density is nothing but current passing per unit area. For example, you are considering any wire here, okay, having cross section area A, and electrons are passing through this cross section area A. So how much current is passing through this smaller part of area is said to be current density. Current passing per unit area. And you also know that I is equal to NEA Vd. Okay. Just now we have derived now previously. So if you substitute here, how much you are getting? I is equal to NEA Vd divided by A gets cancelled. J is equal to Ne into Vd. And you also know what is Vd we got. So Vd means E into capital E by M into tau. Okay. E into capital E by tau by, is it? Understood? So if you substitute this one, how much you are getting? Ne Vd means E into capital E by tau divided by M. Therefore finally you are getting the formula for J. So J is nothing but Ne square capital E into tau by. So J is equal to Ne square tau by M into E here. Understood? And you should also know that current density is nothing but sigma into E. Is it? Why sigma into E? Because you should know that the value of sigma is how much? Ne square tau by. Okay. So here, the next topic is said to be mobility. What do you mean by mobility here? Mobility is nothing but the movement in the electrons when an electric field is applied. What is the meaning of application of electric field? When you are applying certain potential here. When you apply certain potential, there is an electric field created across the conductor. Okay. So what do you mean by this mobility here? Mobility is nothing but current passing through a wire, drift velocity produced in electrons when an electric field is applied to the conductor. So therefore, mobility is nothing but drift velocity produced in electrons when an electric field is applied across the conductor when a potential is applied. When you apply the potential, electric field is developed. Means positive charges and negative charges across the conductor will be developed here, because of which electron starts moving, and therefore drift velocity is created. That means these electrons will take multiple collisions and move forward, which is said to be drift velocity. And whenever a drift velocity is created when you apply electric field, this ratio is said to be mobility here. Okay. So therefore this is said to be mobility. Formula for drift velocity. I told you that drift velocity is nothing but u plus at, where u is said to be 0 initially and a is said to be E into capital E by M. Okay. So therefore drift velocity is nothing but E into capital E by M, and time is nothing but relaxation time, just now I told you already, isn't it? So this is the formula for drift velocity. So this is the basic formula for mobility. And what is the next formula for mobility? You will substitute here. This is the values. E into capital E tau into M divided by E. So E gets cancelled. Mobility is going to become E into tau by M. Okay. So this is going to be the second formula for mobility. Is it okay? So mobility formula. See, resistance is directly proportional to length we said, and resistance is inversely proportional to area of cross section. We already said about this, isn't it? So when you join them, you are getting resistance is directly proportional to L by A. Okay. So resistance is equal to rho L by A, because when you remove the proportionality, you will get a constant, and that is said to be specific resistance. That is said to be rho. Or this can also be called as resistivity. Okay. So rho is said to be specific resistance, and the other name is resistivity, which is reciprocal of conductivity. I told you about this, isn't it? Okay. So this is actually the relation. When length is doubled, what happens? Okay. For example, you are taking a wire of length L. If you take a wire of length 2L, what happens to the resistance? Resistance also doubles, because direct relation. No? If length is doubled, resistance also doubles, because it is direct relation. Okay. For example, length is same. Previously, area of cross section is A. Now, area of cross section has doubled now. Okay. Length is same, but area of cross section is doubled. Then what happens to the resistance? Becomes half. If area is doubles, resistance becomes half here. You know what this is. Length is taken as same here. Okay. So from this you will get one more new relation. What is that? R is equal to rho L by pi r square, isn't it? But because this is a cross section area of a conductor which is just like a circle, which can be taken as pi r square. From this it is understood that resistance is inversely proportional to r square, isn't it? Inversely proportional to radius whole square. So from this it is understood that resistance is directly proportional to length. Resistance is inversely proportional to square of radius. So this is one more relation you are getting here. So what happens when radius doubles? What happens to the resistance when radius doubles? For example, previously radius is r, now radius is going to become 2r. Then previously resistance is r1, now resistance is how much? What happens to the resistance than the previous case here now? What you will do now? Resistance is inversely proportional to r square. We will write r2 by r1 is equal to r1 by r2 whole square. Am I right or not? So r1 is r1 only, r2 is r2 only, r1 is r1. R1 is small r is nothing but this is r1 previously, and now it is doubled radius. So what you do? R1 plus, you just write r, r1 means r, r2 means 2r whole square, getting cancelled here. R2 by r1 is equal to 1 by 4. So resistance is nothing but r by 4. So when radius doubles, resistance becomes 1/4. When radius doubles, resistance becomes 1/4. See, these are all the cases where resistance length is doubled by attaching extra length. Okay. Previously some length was there. Extra wire is added here. These are all extra additions. Previously area of cross section is A. Now we have taken another wire whose area of cross section is double to that of that. Isn't it? Extra lengths are added, extra area is added. But let me discuss the next cases, which are said to be typical cases, which is called as stretching cases. What is the meaning of stretching case? Let us see here now. Previously wire was this much. Now what I am doing? Same wire I am stretching it. Just stretching. Okay. Then if you stretch, what happens? Let me discuss. Here let us imagine length is L1, L2, area of cross section is A1, area of cross section is A2. See, whenever same wire, you are not adding an extra wire, same length, same wire is stretched. What happens? Let us see. Previously L1, now L2. What is going to be same in this case? Can you tell me? Length is not same now. Stretching now. What is going to be same? No. Radius is reduced. Volume is same. Volume will not change. When you stretch the same wire, here also same volume, here also same volume. Now what is going to happen? Let us see. What happens to the resistance? What happens to the resistance? Previously, let the resistance is R1, R2. Now resistance becomes R. What happens to these cases? Let us see. See here, you all know that resistance is nothing but rho L by A. Is it? As it was as in the previous case. But here, volume is said to be constant now. That means area into length is constant. Okay. Understood? So what I am doing now? If I want to replace length here, what will do? Length is equal to constant by area. Okay. So what will get now? Rho. What is going to be constant here? Volume now. I can take volume here, is it? Area into length is equal to volume. So I will take length is equal to volume by area. Length is nothing but volume divided by area, means you will get area A square. So that means here in this case of stretching, resistance is inversely proportional to A square, not inversely proportional to A as in the previous case. This is a typical case which is said to be here actually inversely proportional to A, isn't it? Inversely proportional to A. But here in the case of stretching, resistance is inversely proportional to A square. That means resistance is inversely proportional to pi r square whole square. That means resistance is inversely proportional to pi r power 4. That means resistance here, in this case, resistance is inversely proportional to r power 4. In the case of stretching, especially stretching cases I am talking here. Okay, understood? So this is about the relation between resistance and area of cross section and resistance and the radius of the wire. But what is the relation between resistance and the length in the case of stretching? For that, what I am going to do here, see, resistance is equal to rho L by A. Just now I told you that area into length is equal to volume. Now I will take area is equal to volume by length. Just opposite, instead of L I am taking area here now. So what I am changing here now, rho I am keeping like here only. Okay, divided by area means I will take volume by length, means length comes upwards, means it becomes L square, am I right or not? V by L square. From this it is understood that volume is constant, R is rho is constant. That means resistance is what? Resistance is directly proportional to L square. Okay. So if length doubles, resistance becomes. See, whenever you stretch the wire and make it length double to the previous length, then what happens to the resistance? Previously, if R1 is R, R2 will become 4R. When length doubles, resistance quadruples. Why? What is the reason? Let me discuss about that. Just see here now. I told you resistance is directly proportional to length now. So previously, let us take the length is L. Now the length has been doubled here. I told you in the stretching cases, resistance is directly proportional to L square. Previously, resistance is R1. Now what happens to the resistance? R2 by R1 is equal to L2 by L1 whole square. So R2 by R1 is equal to L2 is how much? 2L by L whole square. R2 is 2L, R1 is L. Getting cancelled. So R2 by R1 is equal to 4. So R2 is equal to how much? 4 times of R1. So resistance becomes 4 times when length doubles. What happens when area of cross section doubles? In the case of stretching, what happens when area of cross section is doubled? For example, previously area of cross section is A. Now area of cross section is, what is happening here? It is becoming A by 2, let us say, okay, or double, anything like this. So 2A, understood? Area of cross section you have to double. Previously what is happening? Previously area of cross section is A. Now you are compressing it, area becomes double. Opposite to stretching, compressing. When you compress, area becomes double, length decreases, isn't it? Or you melt it and make another cylinder of area double. Length has been reduced. When you stretch, length increases, area decreases. When you compress, length decreases, area increases. Then what happens here? I just told you that resistance is inversely proportional to A square. Just now, am I right or not? So previously resistance is R1, then what happens to the new resistance? R2 here. So we can write R2 by R1 is nothing but A1 by A2 whole square, because it is inverse relation. So R2 by R, A1 is how much? A, 2A whole square. R2 by R1, 1 by 4. This implies that R2 is equal to R1 by 4. Is it clear? So these are all switching cases. So let's stop here today. Tomorrow. Let us solve this problem in a super simple way, which is very big problem actually. It's having a massive following with much more information to be given here so that you can understand these matchings here. Let us see what is going to happen now. You all know current is nothing but rate of flow of charge, where Q is nothing but N into E. Number of electrons and charge on the electron. Okay, so this is the formula here. But here, if you see this conductor and it is connected to the battery, let us imagine this is a conductor having length L, which is nothing but drift velocity into time t. Okay, because displacement is nothing but velocity into time here, length is also written as velocity into time here. So therefore, here in this let us imagine there are a number of electrons present in this small wire, in which potential difference is applied here. Let us see what's going to happen now. So current I is nothing but N. What is N here actually? N is nothing but number of electrons in volume V. So this is the wire having volume V here. So how many number of electrons are present in the total volume of this wire whose cross-section area is considered to be A here? So therefore number of electrons is N, volume is nothing but area into length here. Therefore number of electrons is nothing but area into length. Here length is nothing but drift velocity into time here. So according to our formula, you should know that N E by T is our formula. In the place of N, you have to write NA Vd into T into E divided by T. So T gets cancelled. I is nothing but NEAVD. This is the formula for current here. Okay. So once you get the formula for current, then what is the formula for current density? First, let us start from the last. What is the formula for current density? See, current density is nothing but current passing per unit area. Current density is nothing but current passing per unit area. Therefore, which can be taken as NEAVD divided by A. So A gets cancelled. Therefore, J is nothing but NEVD. Okay. So J is nothing but NEVD. So the fourth, that is current density formula, is NEVD. Now, let us discuss about what is the meaning of relaxation period, or first we shall go for drift velocity. What is the meaning of drift velocity? This is said to be the drift velocity here, but let me discuss what is going to happen here. So you all know that, let us consider one electron which is in between one positive and one negative terminal. You should know that this electron force is applied, which is making the electron to move in an electric field from negative to positive. Okay, so here let us imagine the initial velocity. You will find out here, you should know that V is equal to U plus AT according to equations of motion. Initial velocity is 0, V is equal to A into T here. Okay, A into T here. So this is going to be the distance traveled here, and the time taken to travel from here to here is said to be tau, which is taken as relaxation time between the two collisions. Let us imagine what is going to happen. I told you that force F acting on the electron is taken as E into capital E, where force can be taken as MA, which is equal to E into capital E. Because force is given by Q into E according to electrostatics, but charge on a single electron can be taken as Q is equal to N into E, which is Q is equal to E because N equal to 1 here. Because single electron we are considering, so N equal to 1. So then let us see what is going to happen here. Acceleration is going to be E into capital E by M. Therefore, the drift velocity can be taken as, this is drift velocity. That means electron has been drifted, moved from one place to another place. A is considered to be E into capital E by M, and T is taken as relaxation time, that is tau here. So we got the formula for drift velocity, and the formula for drift velocity is this one, E into capital E by M into tau. Therefore, drift velocity formula is going to be this one. Okay. Then what is electrical resistivity here? So B, electrical resistivity. We shall discuss about what is electrical resistivity here. So for that, electrical resistivity you have to find out here. So first of all, we know that I is equal to NEAVD. And just now we got the drift velocity. Another formula for drift velocity is nothing but E into capital E by M into tau here. Okay. So you can just substitute this formula here, N into E into A, and with drift velocity is nothing but E into capital E by M into tau here. So therefore the current formula is NE square A E by M into tau. So you should know that electric field intensity is nothing but electric potential divided by length L. Electric field intensity is nothing but electric potential by length. Then if you substitute here, you will be getting how much? NE square A tau by M. Instead of E, we will write V by L. Okay. Then I can write this as I is equal to V divided by this ML I am writing in the denominator, and this total value I am writing in the denominator, that is NE square A into tau here. Okay. So it is just like V by R. I is equal to V by R, which is said to be Ohm's law here, because V is equal to IR. So just now I got what is the formula here? The new formula for resistance. In the place of resistance, what is present here? So resistance is nothing but M into L by N square A into tau here. Okay. From this, R is equal to, we can write M NE square tau L by A. Okay. So you all know resistance is nothing but rho L by A. Okay. So what is the formula for rho? See, rho is said to be resistivity, which can be written as M by NE square tau here. Okay. So from this, what are we going to get now? What are we going to get now? So he's asking us to find out electrical resistivity. Okay. So electrical resistivity is M by NE square tau. M by NE square tau. M by NE square tau is the electrical resistivity. But relaxation period he is asking. We can take the relaxation period as this one. How? Let us see. Okay. So we got this one. So we can take relaxation period as tau, which can be written as m by ne square rho. Okay, so relaxation time is nothing but m by ne square rho. M by ne square rho, so 3 are over. Then the final thing is you have to find out what is this electrical resistivity, which is E by J, you have to find out, that's it. So electrical resistivity is nothing but E by J. How are we going to find out that one? Let us see here now. First of all, you should know that current density is nothing but I by A, current passing per unit area. And you should know that I just now we got. What is the value of I we got? This is the value for I we got now. Yes. This is going to be the value of our I. I is equal to NEA VD divided by AA gets cancelled. So J is nothing but NEVD, but just now we got VD is nothing but E into capital E by M into tau here. Okay. So this if you substitute here, current density is nothing but NEVD is nothing but E into E by M into tau here. Okay. So this can be taken as NE square E by M into tau. Okay. So what I am going to get now, let us see here. From this it is understood that J is nothing but NE square tau by M into E. Okay. So what is this going to be? This is said to be sigma, which is called as conductivity. R, which can also be taken as, this completely we can write it as E by M divided by NE square and tau. Okay. So this can be taken as E by rho, resistivity. Okay. So what is the formula for resistivity? Let us see. What is our problem actually? Electrical resistivity is taken as E by J. We have to prove that electrical resistivity is nothing but E by J. So therefore, as J is equal to E by rho, rho can be taken as E by J. That's it. So your 4 options are being proved here. Thank you very much. Now this is a previous year question. The number density of free electrons in a copper wire, it is given here. Number density means, what is the meaning of this number density? So number density means it is N is equal to 8 into 10 power 28 per meter cube. This is said to be N value. And whatever is given here now, what else is given? Area of cross section is 2 into 10 power minus 16 meter square. Okay. What else is given? The current carrying I is going to be 3.2 amperes. That's it. He is asking us to find out the drift speed of an electron. Drift speed of an electron. So how can you find out the drift speed here? Okay. You all know I is nothing but NEAVD. Am I right or not? Okay. So we have derived this one. Drift speed is nothing but I by NEA. That's it. A simple formula here which is already explained to you. 3.2 divided by N is nothing but 8 into 10 power 28 into A, which is nothing but 2 into 10 power minus 16 here. So if you solve this one, you'll be getting how much? 125 into 10 power minus 6 meter per second. You'll be getting the answer this one, isn't it? So like this, one more question we shall discuss here of the same type. So here also current in the circuit is given as 2 amperes and cross section area is given as 25 square. This can be taken as 25 into 10 power minus 3 meter whole square. Okay, 1 millimeter is equal to 10 power minus 3 meters. So therefore area is nothing but 25 into 10 power minus 6 meter square. Okay, so like this it is given. What else here? Charge is also given. Drift velocity is asking us to find out drift velocity, isn't it? What else is given? Anything else is given? That's it. 2. What is this? N is also given. N is nothing but 2 into 10 power 28. Okay, per cubic meter. That means per meter cube like this. N value is also given. So same thing is asking drift velocity, the same formula. I is equal to NEA VD is asking us to find out what is VD. So VD is nothing but I by NEA. Okay. So I, what is I value here? That is 2 divided by N is nothing but 2 into 10 power 28 into E is nothing but 1.6 into 10 power minus. Here we have taken no? E, we forgot E here. So here one more thing is missing. That is 1.6 into 10 power minus 19 also have the E value here, NEA. Okay, then you will get this value. Then after that, same thing here also. A is also given. What is the value of A? 25 into 10 power minus 6. So if you calculate this one, is getting 25 into 10 power minus 6. Okay, meters per second. So here also meters per. Now just here, the resistance of a platinum wire. Okay, so let us take a platinum wire. What is the resistance of a platinum wire at 0 degrees Celsius? Let us take it as R0, which is equal to 2 ohms. Temperature is T1, okay, or T0, which is taken as 0 degrees Celsius. And temperature resistance of a platinum wire 0 degrees Celsius. And at certain temperature T, that is 6.8 ohms, its temperature has been, resistance has been increased. And what is the temperature here? Temperature is taken as 80 degrees Celsius. Okay. So when temperature increases, resistance also increases. Okay. Then what is the temperature coefficient of resistance is asking. Now just say here, you all know resistance is directly proportional to length, am I right or not? Yes. As the length increases, resistance also has to increase. You know coefficient of expansion in the case of first year. What are we going right now? L2 minus L1 by L1 into T2 minus T1. This is said to be coefficient of expansion, linear coefficient of expansion in first year. L2 minus L1 by L1 into T2 minus T1. Here also the same thing you write. Instead of length you will take resistance, that's it. So the same thing you will substitute here. L2 means you write RT, which is taken as R2, R1. This is R1. So R2 minus R1, R2 minus R0 divided by R0 into T2 minus T1, which is nothing but T minus T0 here. Okay. So therefore, if you substitute here, RT is how much? 6.8 minus R0 is 2 divided by 2 into T minus T0, which is nothing but, so how much you will be getting here now? Is going to be how much? 4.8 divided by 2 into 80, which is 2 1s, 2 4s, 8. Okay. So we are getting how much? 2.4 divided by 80. You have to calculate this one. How much you are getting? Let us see. So 2.4 divided by 80 means you can write it as 24 divided by 8. Here also one multiply with one more 0. 24 by 800 you are getting. So can you write this as 24 by 8 into 10 power minus 2? 8 1s, 8 3. So 3 into 10 power minus 2 is going to be your answer. C option. Okay. Now resistance of a carbon is determined to be this much value. So here one more problem is there. 22,000 plus or minus 5 degrees. So 22,000 plus or minus 5%. So this is the resistance given here. Okay. What is the color of the third band he is asking? What is the color of the third band here? So how are you going to find out the color of a third band here? For that you should know what is the meaning of resistance color code. You should learn resistance color code here. Okay. So what is the meaning of resistance color code here? For that you should remember that BB Roy goes Bombay via Gateway. Okay. See, this is a code language you have to remember. B Roy goes Bombay via Gateway. So what is that code language? B Roy goes Bombay via Gateway. Okay. From this you have to select this BB ROY GB via Gateway. So this is the order to remember. Okay. BB Roy goes Bombay via Gateway. Understood? So what is the meaning of first B is taken as black. Paka color. Black is the darkest color. Next little bit lighter one which is taken as blue. This is red, orange, yellow, green, blue, black. So let us, after that brown is left. Okay. So lightness is increasing. See, black. After that less dark is blue. Still less dark is brown. Via means violet. Okay. So G means grey. No? This is said to be white color. Okay. Grey white. Understood? So this is the order we have to remember here. So with this order, what are we going to do? See, you have to take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here again 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4, 10 power 5, 10 power 6, 10 power 7, 10 power 8, 10 power 9. See here, for example, what is the resistance symbol here? Resistance will be like this. Okay. The resistor will be like this. And how it will be? First, it will be having some colors like this. 1, 2, 3, and at last there is one color here. Okay. So first color, let us take the first color is red, brown, and this is green, and last one this is gold. Okay. So a resistor is having 4 colors. By seeing this, you can find out what is the resistance of this by seeing these colors. How can you find out that one? First color represents the number here. Okay. So what is the first color? Red means you have taken 2. Understood? So what is the second color is also representing number only. Blue. What is the very blue? Blue means 1. So 21. Third color represents power. Okay. So first two color represents what? This is also number. Whereas the third color green represents power. Okay. And this represents tolerance. That means how much this resistance is able to tolerate. So 21. Third color represents power. What is the power here? Green, no? So green means 10 power 5. Gold means plus or minus 5%. Okay. So there are two colors for tolerance. Gold, okay, and silver. For example, if you take gold, tolerance is for plus or minus 5%. So silver is having tolerance plus or minus 10%. Okay. So gold is costly, person is having lesser percentage of gold, but more percentage of silver, 10% tolerance. Like this you have to solve it. Okay. This is our problem actually. You just see the problem which is given. Okay. What is the problem given here? 22,000 plus or minus 5%. So what is the problem here? 22,000 means 10 power 3. Okay. Plus or minus 5%. Is it? This is the problem. Is it? So first means 2. What is 2? So first color in your, so if I am taking a resistance, 1, 2, 3 and here tolerance. So first color 2 means what? Second color red only. Third color 10 power 3 and this is gold. Okay. So from this, what is the question here actually? Just see. The color of the third band will be how much? Third band. What is the color of third band? Orange. Understood? How to find out the resistance of this color code? Okay. I think with that you can do any problem of the type. The reciprocal of resistance means opposition to the flow of electrons. Conductance means allowing electrons. So opposition to resistance is conductance. Understood? Conductance. Okay. Now, as the temperature increases the electrical resistance, what happens? Okay, just see here now. I am taking two materials. For example, let us take this is a conductor. Okay, this is a semiconductor. So in conductor, population of electrons will be more, very high. Whereas in semiconductor, population of electrons is very low. Understood? Okay. So when temperature increases in conductor, what happens? That temperature acts as ionization energy. More free electrons are produced. So when temperature increases, what happens? Population of electrons also increase. Understand? Traffic will be more. Opposition power also more. So when temperature increases in conductor, what increases? Resistance still increases. Because population increases. There is more difficult for electrons to move. Whereas in semiconductor, there are very less free electrons. If you increase the temperature, little bit more electrons will be there. So here, what happens? Conductivity increases here. Conductivity increases here. Here already population, millions and millions of free electrons are there. If temperature increases, population still increases, just like traffic jam. They will not move properly. So what is the correct option? Can you tell me now? Increases in conductors but decreases in semiconductors. What is that increasing? Resistance. Indulo resistance increase avutundi, indulo decrease avutundi resistance. And conductivity increase avutundi. Having length 10 meters. What is the resistance? 10 ohms. And what is the current density means J. Alright? Okay. Current density is how much? The density in the wire. You have to find out current density. Am I right or not? And what is given here now? Radius is given. What is the radius here? 10 power minus 2 divided by, this is the radius. So he's asking us to find out the current density. Is it? Okay. So what is the formula for current density? Is sigma E. Am I right? So E is also given. Electrical field is also given. E is how much? 10 volts per meter. But here he's asking about, let us take, instead of conductivity, we can take, because conductivity is reciprocal of resistivity. And what is resistivity is nothing but, actually here, R is nothing but rho L by A. So rho is nothing but RA by L. So current density is nothing but E. E by rho means you can write RA by L. So the required formula is this one. You can use this formula and solve this problem. Okay, but small changes you need to do here. What is that? J is equal to E into L divided by R into pi R square. Because R is given, radius is given here, isn't it? Okay, so therefore you can just substitute here. What is E value? What is the length? 10. What is the radius? 10 power minus 2 divided by pi. Okay, so pi can I take in the numerator? Pi. And still into, already here also pi is there. Radius we have taken now. The resistance is how much? What is the, see, radius I have taken here, resistance I have to take here, isn't it? What is the resistance given? So 10 square we have taken now. So can you do this problem now just by substituting? You can just substitute the values and get the answer. Now let us go for the next problem. You just see here. This is a case of stretching, okay? Stretching of a wire. See, previously the wire was this much, okay? You have stretched the wire. When you stretch the wire, length will increase, area of cross section will decrease, but what is going to be same? Volume is going to be same, isn't it? So he's asking us to find out what is the relation between resistance and length. You all know resistance is nothing but rho L by A. Volume is nothing but area into length. Area is nothing but volume by length. So therefore rho L by A. A means, so length comes numerator, becomes is going to be constant here. We should remove this one, and specific resistance is also constant. So resistance is directly proportional to L square. Okay. So if length is increased by 20%, what does it mean? See, previously length was this much. Here 20% length is increased. So totally how much it becomes now? It becomes 120%. Length becomes 120%. Understood? So here, see, what you'll do, R2 by R1 is equal to L2 by L1, isn't it? Previously it was 100%, now it has become 120%, whole square, isn't it? So, whole square. So L2 is how much? 120 divided by 100, whole square. So how much it will become? Actually 2 zeros means it becomes 1.2 whole square, no? So cancel 1.2 whole square means how much? It is going to become 1.4. 12 is 144. 12 is 144. So 1.4. Understood? So 1.44 means what is the meaning? How much is going to be extra? See, 120 by 100 means 1.2. 1.4 means what? 140 by 144 by 100, no? 1.2. 120 by 100 means 1.2. 140, 1.4 means 145 by 100, no? 144 by 100 means how much is extra? 44% is extra. Simple technique. Understood? And what else? Now, the length of a cylinder is increased by 100% due to consequent decrease in the diameter. Means what is the meaning here? When length increases, diameter decreases means stretching case. This also indirectly he's telling. This is also a stretching case. What is the meaning of this stretching case here? Previously it was 100%. Now, how much it is? 200%. It is going to be 200%. 200%. So length has become doubled, 200% here. Is it? So what is going to happen if it becomes 200% here? R2 by R1 is equal to L2 by L1 whole square. So R2 by R1, L2 is how much? 200 divided by 100 whole square, means it cancels, becomes 4. Okay, so what is the meaning of 4? Is it not 400 by 100? Just like here, 2 you are getting, 400 is left means what? 400 by 100, can you write? So 400 by 100 means extra how much? 100% it was there, now it has become 400%, means how much extra? 300 is extra, very good. So this is going to be your answer, that is your answer. See, we shall discuss about what is the meaning of series and parallel resistances. How do you find out what is happening in the series? Okay, during series connection what happens? During parallel connection what happens? Okay, so whatever the potential you are connecting, it is divided here. Sum of the potential V1 here and potential is here is V2. Okay, see what are you going to observe here? Potential is divided. Current is okay. So in the parallel connection, current I up to here, current is divided. Okay, here potential, here also potential V, here also potential V. See, this is separately connected here. This is also separately connected to the potential. Therefore, potential remains same here. Current is divided. Here, current remains same. Potential is divided. That thing you have to remember. That's it. So this is series connection. In series connection, you have write what you have write V is equal to V1 plus V2. In parallel connection, you have write I is equal to I1 plus I2 because current is divided here, isn't it? So here, according to Ohm's law, you write V is equal to R series, I into R series, I R1 plus I R2. Current is same in this case, so current gets cancelled, R1 plus R2. Here, I is equal to V by R, so V by R parallel, V by R1, V by, so potential is same here, so gets cancelled here. So parallel connection is nothing but 1 by R1 plus 1 by R2. If you take LCM, R parallel becomes R1 by R1 plus R2. Okay. So this is going to happen in the case of parallel connection, in the case of series connection. Understood? Next, we shall give you one diagram here now. Now you have to say what is going to happen in these cases, in such type of cases here. Okay. Okay. So this is a connection given. This is A and this is B. He is asking us to find out what is the resistance across AB. So what type of circuit it is, how can you solve, which is series, which is parallel, little bit confusing. So there is one technique here. You should remember one thing, that this is a symmetric circuit. What type of circuit it is? It is going to represent symmetry or not? Symmetry means what is the meaning here? Whatever the line in the middle comes here, that should be disconnected. Whenever symmetry comes, what should you do here? These two lines you have to join and these two lines you have to join. Okay? Now you can solve easily. What is that you are going to solve here? You can convert this into one circuit where now this is converted like this. One is resistance R. These two taken as 2R. Again in the middle 2R. Again in the last R. Okay. So 2R, R. See, in the parallel connections, when the resistance are same, then the shortcut formula is R by N. Means what? When two resistors are same and parallel, then answer will be R by N. Means 2 are there, no? So R net is going to become R by N. Means here 2R by N. N means how many are parallel? 2 are parallel. So 2 resistance is R. So these two combination you will get resistance R. Then R, 3 are parallel. R, parallel. So according to the same formula, R parallel is going to become R by N, which is nothing but R by, understood? R by 3. So your formula for this case is R across AB is taken as R by 3, no? R by 3. For example, he has given all the, when this type of circuits are given, when all the resistors are 10 ohms, so then your answer is going to be how much? By 3 ohms. If it is given as 30 ohms, then R across AB is directly taken as 30 by 3, which is taken as 10 ohms. Like this we have to solve, okay?